All right, so Karellas? Jim Karellas came to CSC NASA 4.5 years ago from a Department of Defense project that was hosted at Ames Research Center at NASA Advanced Supercomputing Division. He's run the Lustre project for 4 years. His time is mostly spent on other HPC systems projects for NASA. And Jim.
Hi, my co-author couldn't make it down today, so if you don't like the talk, then it's all his fault. If you like it, it's all me. So, okay, so we're going to talk about multiple interface Lustre performance from a single large client. The motivation for the talk was, well, the real motivation is we have a much better shot at getting approved for travel and conferences if we give a talk. So, so that's why I'm here. So we have multiple file systems connected to Pleiades that a lot of other systems touch. We just integrate into our I/O fabric. And the main motivation is that Columbia, many of you may remember Columbia. It's been around a long time. We were finally able to retire it and get a replacement in for it. It's actually two systems. We have two SGI UV2000 systems. One is bigger than the other, so when I refer to Endeavor, it's really referring to Endeavor 2. It's got 4 terabytes of memory, 1,024 cores. On Columbia, we, just as a point of reference, another SSI system, we were able to benchmark it with 8 SDR cards, InfiniBand cards, and we were able to get 3 gigabytes a second out of it. So the requirements for the run, oh sorry, that was all motivation. So requirements for the runs were that we need to be able to control the connection for each OSS using multiple NIDs. We want the ability to add more interfaces as we move forward, possibly, if we get performance up to where we want it. That's the first clue. Performance ended up not being so good. And no need for special IP range addressing. That's what we ended up using when we benchmarked Columbia, and we wanted something simpler. So with this slide, we basically wanted to show the NID layout for a generic system. This is not how we configured Endeavor, just for a generic example. The NIDs in white would be how you would configure it on a single rail IIB system. If you look at the stuff in Aqua, I believe that shows up. That's how you do an example of how you would do NID placement. So you basically take the NIDs from each of the OSSs and MDS, and you have some leeway in how you want to assign it per interface on the large host. I tend to like doing things that involve symmetry, so it's pretty. There's not a lot of things you could do with it, but you can certainly test things out and see if you get different performance with it. So this slide might be hard to see. I highlighted the MDSs in red so you don't focus on that, and again, focus on the symmetry of the NID placement. So this is the actual NID placement for the Endeavor runs for rails 2 through 6. If you notice, we have 12 OSSs on the back end. So if you notice, we have 12 is a multiple of 2, 3, 4, and 6. So placement is pretty straightforward again. Rail 5 gets a little interesting in that we had to add an extra one to a couple of them there, a couple of the interfaces. This is what etcmodprobe.d/lustre or lustre.conf, depending upon which OS you're using, would look like. The first half of the slide is for a single port, single rail. what we typically use on Pleiades. I didn't want to inundate you with all the configs, so I just chose one at random. So for 4 ports, this is what it would look like. Again, pretty standard so far. Benchmarks. So this is where, you know, we're not benchmarking for real-world performance here. We tend to use IOR a lot. We use other benchmarks too, but for this particular one, we chose IOR for no particular reason. Basically, each task is defined as reading or writing 1 stripe file per OST, 1 megabyte block size, 1 gigabyte files, and using direct I/O. Well, some of you may disagree. Well, benchmarks tend to invoke passion in some people. We just tried to go with hero numbers, basically, and we're basically not trying to show real-world performance. We're trying to show one interface versus, as it scales up to 6 interfaces, what the performance would be like. So again, we're not going to give too much information about the back end. It is a NetApp E5400 system. We did benchmark it with Pleiades using multiple nodes, and we're able to get greater than 7 gigabytes a second. So software versions, we're using Sense 6.3 on the server, Lustre 2.1.4 with additional patches. We always tend to have additional patches. And OFED 1.5.4. On the client, we actually had, since we have 2 endeavors, on one of them we put Sense 6.3, and Sense 6.3 comes with a 2.6 kernel. SLES 11 SP2 comes with the kernel 3.x. So we decided that the users would get more benefit on a big SSI system using a 3.x kernel now. That may change with RHEL 7x or Cent 7x. So we may switch back to Cent at some point. But that limited, the important part here is that limited the versions of Lustre that are supported by our vendor, which is Intel or WAM Cloud. So we were kind of forced to use Lustre 2.3. I don't think that had anything to do with the performance we saw, but it may. So the first graph, I don't know how well this is going to show up. Again, results were quite disappointing. Sequential writes, you see a kind of an anomaly at 108 tasks. We get just above, what is that, 2.5 gigabytes a second with Rail 5. So it almost looks as if Rail 5 is the best solution in this case, but when a couple slides from now we'll look at the averages, and you'll see that it was not the clear winner. It actually dovetails off quite a bit. Same thing with reads, very similar graph. These peak right above 2 gigabytes a second. And I should mention, I didn't mention in our hardware specs that we are using FDR InfiniBand from Endeavor into Pleiades. So we did expect much better performance. So here's the most interesting slide, is to average over the number of tasks. We kind of got a parabolic shaped curve here, except Rail 3. We don't know what happened with Rail 3. I should state this experiment or this test was truly done to get us here to present something. It was on our list to do, but we only had the system for a few hours to benchmark it. So we didn't have as much time to dive into details like we normally do and figure out what was going on. So we can't explain Rail 3 here. And Rail and Port are interchangeable in this talk. So it got interesting as we, especially Rail 6, it really dovetailed off there. Okay, so conclusions and future work. As I stated already, we were quite disappointed with results. We don't know if it was any fault of Lustre at this stage. We have a few ideas, which I'll get into in a second here. Rail 4 did produce the best results according to the averages. If you look at averages, again, we're not benchmarking real world workloads here. So what are we going to do? We're going to investigate LNet tuning. We're going to read the client code, see if we can find anything in there that would benefit us. HCA or InfiniBand card port placement in NUMA SSI systems is relevant. This is probably the biggest thing. We know from our experience with Columbia that where we put I/O is important in the system, physically in the system. And the connection location in the IB fabric is relevant. It needs analysis. I was talking with a coworker yesterday, and the graph, this graph would go peak and then level out if that were the bottleneck. So I don't think that's the bottleneck, but we didn't take into consideration we had cable issues. Endeavor sits in another room, and we had cable length issues to where I remember we barely got it to where it needed to go. But we're going to look at that further and see if we can fine-tune that. And that's all I had. Any questions? Any solutions first? No? Questions?
So with the HCA placement, do you actually have any underlying ideas about why one HCA placement works differently from another? Or
Sure, because in a NUMA-based system, it's all based. I'm not a NUMA expert. I'm not an SSI expert either. But it sees the entire system is seen as like an underlying bus, think of it as a PCI bus. And when you are writing from the furthest node in the system to where the I/O goes out into the fabric and hits storage, you're going to have much more latency than and you're going to get much worse performance than if you spread the cards out in an optimal way. So that to get to I/O from this node over here, you only have to go a couple of hops in the system to get out to I/O versus having to traverse the whole system. That make sense? Kind of.
I have two questions. Number one was that you said there's 2 computer clusters that are accessing this file system, right?
I'm sorry, there's multiple computer systems accessing the I/O fabric on Pleiades.
Okay.
So Pleiades is our big system, and then we have our visual system called the Hyperwall, and it connects into our IB1 fabric. We also have the 2 Endeavors. We have some Intel-based mic systems, or one, and we're getting another one in. And we took apart Columbia, so we don't have Columbia anymore.
And so what's the situation with the metadata server? Do you have one metadata server for entire files?
On this particular system, we have 7 file systems. On this file system, it's our test file system right now. We haven't put it in production yet. So it was solely being used for this test purpose.
It's only one metadata server?
One metadata server,
okay,
correct.
Thanks.
Yeah. With 12 OSSs.
Do you have LNet self-test results?
We don't. Sorry. We will be going through in detail and when we fine tune it. So if anyone if anyone is interested in this and how we fix it, I can definitely post how we fixed it because we will fix it. But
I have a piece of information. Lustre 2.3 and 2.4, you can manage this CPU distribution, and you can bind LNet interface on a specific CPU NUMA node. So it's probably something you can try.
okay. Definitely. Thank you.
Here's that question.
So I apologize if I missed this up. I didn't see. Do you have results for Lustre performance on, say, a similar client as far as like something that's not a large SMP system, but also has like a FDR interface and connects to the same file system?
We don't have from a single client. No, we don't.
Yeah. Okay.
We just have the results from multiple clients on Pleiades. That would be a good test to show, though.
Because we had a similar setup. We had an SGI UV with multiple IB interfaces, and it was QDR. But testing I had done, one of the things, and not only did we find that the multi-rail didn't scale well, but that even just with a single rail, the performance from that one client was typically far less than a similar single client with a QDR IB interface that wasn't a big SMP system. So I was curious if you had seen similar results from that.
So one of the things we may end up doing if we can't get this working correctly is since we have 7 file systems, we're actually getting an 8th file system in soon, is we could just dedicate a single port to a single file system if that's what we have to do, and we can't get performance to scale. So I don't know, do we blame Lustre for that, or do we blame SGI for that?
But yeah. I would say both.
We always, I've kind of run the Lustre team. We all do multiple things, but for me, it's always an IB issue, and for the IB guys, it's always a Lustre issue. So we keep going back and forth.
Thanks a lot, Jim.
Thank you.